Well, hello everyone. What's going on? It's been a little while. I've been very busy lately. I guess to some extent I still am. But hello Nolram. Welcome back to you. Right, let's see if I can remember to actually do these things. Can you guys hear me? Good enough, well enough. Is the audio levels... Are the audio levels suitable? And all of that. How are we doing? So, I indeed haven't been streaming for a while. I've been doing some pretty thorough, some pretty deep-reaching tech work lately, and it's been sort of a snowball slash rabbit hole sort of thing, where it just sort of kept on going and going and going and never stopping until until I basically decided, okay, enough is enough. Let's do a little bit of streaming to let you guys know that I'm alive still. Audio levels seem good. That's good to hear. I can almost not remember how to do this streaming anymore. It's been like a month. So do let me know if something is mucked up later on. But let's assume it is going to be alright. So, how's everyone doing? This is gonna be a pretty chill, laid back sort of thing today. I've been working on game modding, essentially. Kind of like two things in one. They're both related to game modding. If you haven't been around for a little while, I did release a first playable pre-alpha 1 version of the game about a month ago. It's actually exactly 1 month ago, because it was the 1st of February and now it's the 1st of March. So you can actually play the game now if you want to. It's a pretty rough build, I should warn you. I've gotten a lot of excellent feedback from it. Some of the things I've already started working on. Some of the things I haven't, but I will. And so it's a pretty rough build, but if you want to play it, you can play it. And the way you do that is by joining the Discord. There should be a link down below. And so there was quite a bit of hustle on the Discord around that time, and then it's been kind of silent. And it's mostly my fault, one might say, because I've just been so very busy with other things. The biggest of which is mod support. Nolan says, I'm super happy to see you tackle modding. I'm always happy to see games that have it. Being able to support modding well is probably one of the biggest benefits of a custom engine. I would tend to agree, yeah. Although I've seen some pretty impressive modability in games that use off-the-shelf engines as well. But of course, if you're doing your own stuff, then you can just basically do whatever you want, really. And it should probably be... how should I explain this? Some of you might be wondering, okay, why am I doing modding now when there's like the game isn't out and probably won't be out for like at least another year or some. But there's a point to all of this. If you want to do modding well, you have to kind of plan ahead for it a little bit. There's some tech work that you can do. I mean, you can mod games that don't really have support for it, if you want to. If you're dedicated enough, you can probably mod pretty much anything. But if you give the players some help with that, then they typically produce cooler stuff. And it's easier to do that if you kind of start working on it relatively soon. Relatively early, I should say. And so that's kind of the idea here, that like, even though we don't have a product yet, so to speak, it makes sense to start working on modding support already now. And of course the reason I would want mod support is that I think this game kind of, the modding would fit this game pretty well, seeing as it is sort of like a physics-driven sandbox sort of core game loop, right? You have vehicles driving around and behaving somewhat realistically according to the physics. That should allow for a pretty good sort of base for just anyone who wants to go like, oh, I want to implement like a, I don't know, like a tracked vehicle or something. So that is kind of like the reason why I'm looking into modding support right now. It's not something that I'm gonna like spend necessarily most of my time with for very long. I want to get a pretty solid kind of tech foundation in for the modding, and then hopefully it will just kind of keep working in the background, and I can get back to other things. I have a lot of my to-do list, as I'm sure you'll realize if you see all the feedback that came in from the first build, and also of course we have a lot of other things in the game that we want to put in, like other levels and vehicles and missions and everything, features. Anyway, so what's going on? Well, I've been working on two things, like I said. Mod support. So basically just being able to add more stuff to the game without having to necessarily modify the game itself. Like the game can be installed through something like Steam, and then maybe you could add more things by using something like Steam Workshop or whatever. That's like one thing. And another thing is WebAssembly or WASM support. So some of you might actually have seen this already. You can see here in the console here. Hello from the test mod WASM client, and WASM of course is WebAssembly. Hello from the test mod WASM server. So there's clearly already something going on here, right? If we add a test object here, test mod test object from the command prompt, you can see it now has something called test mod component, which writes essentially just like every second it writes something. There's also this mysterious red debug sphere that has appeared here over in this part of the level. And while this doesn't look very impressive necessarily, it actually took almost like a month for me to do this, because none of this stuff is actually part of the game. It's all loaded from outside the game folder, and it is not compiled to native code. It's compiled to WebAssembly and running here in the game. And that's been like quite a bit of work, let's just say. And it's not done yet by any means. That's what we're gonna play around with it a little bit today in this stream. It doesn't look very impressive, but it is, yes. Yeah, that is. Especially when it comes to like programming, it's just like, look at this. I got a text here, and like half of the people are celebrating and congratulating the creator, and the other half is like, what? Why are you so excited about a text or something? If we shut down the game, or exit here. Actually, we need to exit completely. Actually, we can't see it because the console went away. But the mod says something about being unloaded there. Sebastian says, very cool. I guess the goal is to enable performant and somewhat secure mods. Exactly. That is exactly the goal here. So let me just try to explain this a little bit. I'm drawing with the mouse here, so this is going to look just positively horrible. But if we have a few layers here, right? We have the engine here. Engine, which is C++, down below. Then we have the game. Game. This is even more difficult to to draw this than I thought it would. Let's see if I can manage. Right, on top of the engine we have the game, which is Zig, and it is compiled to a DLL, which is running inside. Running on top of the engine, right? And the new thing is that we can have other libraries that we can load from outside the game. These can technically, I guess, be written in any C or WASM compiled or compatible language, but like SIG is kind of like the prime candidate here. That's the only language that I'm providing a library for. These can also be compiled to DLLs. That's important to know. But WebAssembly is going to be kind of like or I'm trying to make it the main mod language, just because WebAssembly prevents a malicious mod maker from like mining cryptocurrency or you know, trying to access your personal information or whatever on your computer. And I don't want to have to deal with like the whole Minecraft mod situation where like every other mod is, well, not necessarily every other, but like a significant amount of mods had at least at some point they had like malware in them. So that makes WebAssembly kind of interesting. I'm trying to make it completely for some definition of completely, but trying to make it transparent both for the user of the mods and for the writer of the mods. That is the sort of DLL/WebAssembly split here. But this is the idea. So if we look here in this is a trampoline app. This is just hard coded currently. We have this thing here, which is like a new sort of. I actually even have a comment here for how this is going to work eventually. But we have something called a mod manager now. This is a completely new system. The mod manager accepts a vector of mod descriptions. Mod description is something that describes a singular mod. The mod has an ID, has a name, has an author, a version, has a mod SDK version number. So this is kind of like if I make some drastic change to the game, the mod needs to be able to figure out, is it compatible with this version of the game or not. And the mod can have a library of code that it can load. This can be a WASM file, as it is currently here, or it can be a DLL file. So you just switch it like that, and now it's loading a DLL. DLLs, of course, are not sandboxed in any way, shape, or form. So loading a DLL will essentially how should I put this? DLLs will probably work kind of better in air quotes than a WASM, seeing as the whole game is actually a DLL, so it will be more kind of more similar to how the actual core game works. And there will probably be some things that I won't actually expose to WASM. It will only work with DLLs. But of course, the DLLs are not sandboxed, so they're not as secure as the WASM stuff. And then finally, a mod can also have a number of resource packs. So you can add things like textures, 3D models, levels, scripts, whatever, to your mods. Let's see, do the mod modules have access to the game memory state directly, or must they do everything through function calls? So if you are if you're loading a DLL, they will live in the same memory space as the game, because it's just like it essentially boils down to calling load library, and the core game itself does a lot of straight like pointer reads and writes directly with the game engine itself, which is of course very, very good, because like that makes it efficient. WebAssembly cannot do that, just unless you have a very cursed WebAssembly runtime. Like the WebAssembly, the whole idea of WebAssembly is that you shouldn't be able to do that. That comes with like a whole bucket load of complications. Yeah, for WASM it's not possible. No, not currently. I'm using. Let's see if I can find it here. So this is what I'm using as the runtime for running these WebAssembly things. The WebAssembly micro runtime. Oh, this just zooms all of my Chrome windows. Let's not do that. Yes, so I'm trying to kind of abstract away the runtime as much as possible, so that so I can switch this out for something else if I need to. So far, it's been pretty good. I've had some really quite cryptic issues recently with threading. WebAssembly threading is kind of not that well supported yet, so I had to kind of the threading is done currently differently for the WASM modules than it is for the DLLs. And this WAMR, so WAMR, WAMR, this guy kind of didn't handle threading all that well. It supposedly supports like even WASI threads and things like that, but I had some issues with it. Not to mention that the SIG WASM allocator doesn't seem to be multi-threaded yet. It just like gives you a compile error if you try to build it. So I kind of split the client and the server in the mod so that they have their own modules that run on different threads. And that kind of solved it for me, but of course you can imagine it was a bit of a hassle to make that work. So what does this actually now look like then on the code side? So here we have the game. If we have some new people here who don't know what means is essentially traction point. It is the game. It's just like the kind of code name for the game, and it will kind of remain the code name for the game. So you see a lot of means here in the code and the like files and everything. So if we go to release, here we have means game.dll. That's the actual game. It's 4 megs apparently. I think that's a debug build actually. It's usually much smaller in release mode. So that's a Zig DLL, and it is this thing here. Means there's a build script, obviously. There's some libraries here. Now we have test mod. This guy. So I'm trying to kind of mimic the SDK, if you will, for the mods. Almost 100%, but not exactly. You look at the build script here for the actual game. Oh no, actually not the build script, but let's go to main.zig for the actual game. Can't seem to find the right file here. Right, you should see some similarities here within the actual the mod and the game itself. Like we start by kind of selecting an allocator. So here we are essentially using the WASM allocator. So this is the mod, so WASM allocator here on the WASM side, and heap allocator otherwise. And of course, if we're building this mod as a DLL, it can use the actual game engine's own stuff. And then here in init library, which gets called when this library is loaded, here we create an app. The application means app, which is kind of like the game app, if you will. Here on the mod side, we are instead creating a mod controller, which kind of acts as sort of like this mod's app. You get to hook into like the main loop and things like that with it. And also kind of interestingly, you can register components here, the game object components, completely in the same way as you can do for the actual game itself. So that is very handy. And then the game does some other things here that we're not super interested in. The mod controller looks like this currently. So these are the outputs that we saw. Hello from the test mod. We saw this twice. So the game, as I said, currently creates 2 separate module instances for the WASM version. If you build this to a DLL, it will be essentially like the same object, the same instance of this struct here, and then it just prints it here. The mod controller doesn't do a whole lot, but it can do. You can do, server created, server destroyed, client update, client tick. You can hook into various parts of the main loop here if you just need to do some stuff. And then of course we have the actual game object. So we created a game object which uses a new type of component which is called test mod component. And when that is being updated, it draws this sphere, and that was the red sphere that we saw. So everything should look, if you've been following me for a while, everything here should look basically exactly like the code for the game itself, right? You give it a registration name. I'm trying to come up with some sort of sensible kind of best practices here, so that you have this mod ID, which is supposed to be unique for the mod that you're loading. It's the same thing used here. We're actually loading the mod. Obviously, like, the game will need to scan some folder to find the mods in it, and then sort of do this based on what it finds in that folder, and then you should be able to enable and disable mods and even reorder them so that certain things are perhaps updated before other things, etc., etc. But for the time being, this is just hard coded. But yeah, you should use some, or I should come up with some sort of conventions here for how we actually name things, so that mods can coexist in harmony, and also they shouldn't interfere with the actual game, like data or components. Anyway, this stuff. This is essentially all that the mod does currently. This is just keeping the mod controller pointer somewhere. We looked at that already. This is all the code that's in the mod currently. So not very much. If we go to the actual file system, then you can see that we have a folder here called means mods, and this is where the actual source for this stuff is that we just looked at. But it has an output folder, and this is again me kind of trying to come up with a convention for, like, hey, how would a folder look like where the game could then just go in and, like, not evaluate, but enumerate all of the mods in it to put into some list. so that you can then choose which one you actually want to load and so on. And so again here we have this folder test mod, which is supposed to be named the same as the actual mod ID. It has a JSON file, and again it kind of contains the same info. This file is actually not even read anywhere. I just kind of put that there as an example to myself. And it has a DLL and a WASM and a BP4, so a pack file essentially. And so how would we now then, if we just like deleted all of that, for example, boop, go away. How would we build this? And let's see if I can actually. I don't think I've ever built it on this machine. But let's see if we can do that. So it means mods, test mod, and here we have a build zig. So we should be able to build this, and it should actually be set up to output it. Yeah, you can see it here. exe dir directory. So it's the exe directory, even though it's technically like a library. WASM actually wants you currently in Zig to use add executable, while the DLL uses shared library. Which WASM runtime are you using? I'm using the WebAssembly micro runtime currently. Remains to be seen if that works out in the end. But it looks pretty promising. I can go into some details about things being tricky in a little bit. Let's see if we can actually build this mod here on this machine now. So where was it? Here. So I want a WASM or a DLL file to show up there, and I think it was Zig build. Is it help? Nope. Evidently not. Oh, it is. Okay. Yeah. Okay. It just needs to kind of figure out some of these things to show us here. Right. So I added a flag. Look like this. Build as WASM. You can kind of override that if you want. So by default, it clearly produces a WASM file for us. It's 1.2 megs. It's kind of large considering we're almost not doing anything, but it's worth keeping in mind that we're actually bundling like a significant part of the game engine's stuff along with it, as well as a significant part of the Zig standard library as well, which the game engine uses. So if we do build as WASM equals false, it doesn't work. What? Oh, I need to put a dash in front of it. Oh, there we go. Now we have a DLL. And now we can just load this DLL just as easily as we load the WASM. We just need to, since this is hard-coded stuff still, just make that DLL, and now if I run the game, it should do exactly the same. Let's get the volume out of here. So we should see it somewhere here if we look in the list. There we go. There's our mod, test mod loaded. So that's pretty cool. Or I think it's pretty cool, because that means that we can have mod makers create mods using a single unified SDK, which just so happens to be the same SDK I use to actually build the game itself, right? And if they make a mod that is really nice and cool and everyone loves, then maybe we can work out a system where I actually allow them to build it as a DLL, if it is kind of like a known mod maker. Nice, so you can use a regular debugger while working on the mods. You can, yes, absolutely. Absolutely. You don't need anything except you need Zig, obviously, and you need my mod SDK, which consists of the interfaces needed by the game engine, and then you can just essentially work in DLL land if you want to, and just use a regular debugger to debug everything. As long as you make sure that your stuff does actually compile to WASM, and currently it's just like a fraction of everything the game engine can do that actually builds to WASM. But that's just because it's a work in progress. But like, not everything will necessarily build to WASM in the end. But we'll see. We can figure that out. But there's some things that are like truly kind of tricky to do, specifically because WASM doesn't allow you to do like straight memory reads and writes and all of that. But yeah, that's the idea. The idea is that like a mod maker should just be able to work with DLLs locally if they want to, and then just release their WASM stuff, or release DLL stuff. Maybe we'll allow DLL mods with a disclaimer that, hey, this might do anything to your machine. Be aware. I don't know. I haven't figured out the details yet, but let's try to figure out what can be done first, and then figure out what we actually want to do. Right, so that's pretty cool, I think. If you are unfamiliar with WASM, there's some pretty interesting introspection you can do here on the actual file. There's something called WASM to what, and let's do. Oh, where am I actually? I'm not where I'm supposed to be. Output test mod WASM to what test mod WASM. Let's put that into like a what txt file. Maybe like a config object to allow DLL mods, but leave it off by default. Yeah, something like that. That might be a good thing. So here is like WASM can be visualized in a number of ways. Here is the mod, and a significant part of my Zig SDK in text form. I think some runtimes actually even just run this stuff. I'm not sure if Whammer does it. But if you know a little bit about WASM, you know that it's a stack-based virtual machine. And here we can see the actual instructions being emitted here. Right, so we have a function. There's a little Lisp like this kind of syntax here. Mem allocator create anon. Let's see if we can find one of those functions that we had here in the mod. See what they look like. I'm actually using just straight up the standard ones. That's not very helpful, because there's probably going to be, well, get lib type. Yeah, this function here. See if we can find get lib type. Here we go. Test mod controller get lib type. So this is this stuff is this stuff. So it's just a switch. Just a switch that switch statement which is returns a string literal, and I'm pretty sure that it probably some of these constants. That's actually only one. I don't really know how to read this stuff, to be honest, but I'm sure I could probably figure it out if I spent like a day or two reading about this. Let's see if we can find like WASM client is probably some sort of something in. Here we go. So here's a data section. Data has a bunch of things, and there's WASM client over there. You expose specific engine functionalities through functions. How would a mod iterate through all entities, for example? Right. So, if you are here in the component, this is stuff that it's probably not going to work currently, at least with WASM. But basically, you can use the same SDKs as the game itself. So if we're in tick here, you can do self.context. I should mention at this point that my engine is fairly object oriented. Like the APIs are kind of object oriented, or at least inspired by that. Zig is obviously not an object oriented language. So there's nothing like a base class, for example, for one of these components. So this is just a struct, and so all the components have something called a context, which is sort of like a poor man's base class, essentially. And with this, you can do get game state. Let's actually just put this in game state. And game state then has a bunch of functions here to, get a game object by its name, for example. You can check if it has a game object. You can get game objects from renderables. Not sure if you can actually iterate over the game objects here. I don't think I've ever really needed to do that on the Zig side so far. But if it is something I need, I'm pretty sure I can just expose it from C++. If we do, let's see, what should we do? Let's see if we can do something here. This should at least work in DLL mode. And maybe we can, if it works in DLL mode, we can expose it to WASM. So let's load the DLL mod, and I'm just gonna run the game now. Yeah, so this is exactly kind of the thing that I was thinking I would do today. Just start messing with this and seeing how it works. So this is pretty good stuff. That's player 0, okay? It's player 0. So what if we made it so that rather than just, when we create this object here, it starts just printing this. What if rather than doing that, we get the player object, the object called player 0, and we just print its position every second? I think that is probably a pretty good kind of starting point. So I'm just gonna comment that out actually. And let's do this maybe only on the server, otherwise we're gonna get it twice every time. So we do self context on server, and we can move this thing into there. And then here we can do player object, and we do game state get game object with the name player 0. Like, objects typically have much more complicated names, especially if they're placed in the level editor. But since this object is actually spawned from a spawn point, it just gets a very simple name. So, and if we have such an object, right, PO, then we can world pos, I think world position is right there, right? And then we can do basis print f player pos. How do we visualize a vector? Maybe something like this, and then do like 0.2, 0.3. Let's do 0.3. And then put that in square brackets, and that's like our vector right there. So world pos x, world pos y, world pos Right. Yeah, I know this is not exactly iterating over objects. I think like if we go to game, this is game state. So there's a game state class in C++, gamestate.h, which is actually significantly more complex. And this has a bunch of things for iterating over, if I remember correctly. Yeah, you can get all game objects just into a vector. You can get game objects with a transform. You can get game objects with a physics transform and game objects within, you know, an axis-aligned bounding box. Stuff like that. And yeah, I think that's the one that we looked at there in C. Get game object from renderable. Right, let's see if this works. So, yeah, we can see that this is an optional game object pointer, PTR, and has a question mark there. So we need to check if we actually have one of those guys. Otherwise, it's not gonna do anything. So let's build this as a DLL first, because I'm not sure I have all of this actually exposed to WASM. If it works as a DLL, then let's what did I do? Oh, I'm in the wrong folder again. That makes sense. Test mod. Yeah, there we go. If this works as a DLL, then let's see if we can make it work as WASM. Or well, we can try just building it as WASM, but I'm pretty sure it's not going to work out of the box. Yeah. I'm just loading the level there without going through the campaign, just to skip all the intros and everything. And these coordinates here are actually not used for anything. Just do it like that. Alright, so here we can see player position. And if we start driving around, you can see the player positions are now changing. And they look pretty sane to me. You can look at the middle coordinate there, becoming larger when we drive up onto this rock, and then when we drive downwards here towards the road, they go down. So that looks pretty good. Okay, so now the idea is that this should work exactly the same in WASM. Oh dear. Oh. This is a crash that I get maybe twice a year or something. It's really, really rare. It's in direct input 8, which I know I should replace with something else, something more modern. So about once every 6 months I got a crash in direct input 8 upon shutdown. This has nothing to do with the mods. I just happened to see it here. Let's see. Thanks for explaining. I'm asking because I was pondering using WASM for mods, and I couldn't figure out how I would do these kinds of things well, except by copying game state to the WASM module and back. I assume that a game object pointer would point to memory that WASM can't access. Yes. Yes. So I happen to be in how should I explain this? When I started doing this, I think on the Discord I said that I probably like accidentally created like the perfect environment for doing WASM mods. Now that I've actually done the work, I'm not sure it's it's the perfect environment, but it's still a pretty good environment. So this is a game object in C++. These are kind of similar to like a mono-behavior style Unity game would use, right? It's not a very big class. It has a bunch of functions, yes, but it has actually kind of not that much state. Component lists, a possible transform component, and then some helper stuff. All the interesting stuff are in the components themselves. But still, this is C++ class, and we want to poke at these guys from Zig. How do we do that? Well, we can't really do that because Zig doesn't understand anything about the C++ calling convention, ABI. In fact, not even all C++ compilers understand each other because the C++ ABI is such a wild thing. So what I do in Zig is, oh, that's not the right one. That's the right one. What I do in Zig, see if we can make this a bit larger here as well, is this. I essentially have an opaque pointer, CPP pointer. This is something that I've explained a number of times on the stream, but I don't mind explaining it whenever someone asks, because it's not obvious how to do this. And this is not necessarily the best way to do it, but it's a way that can be done. So you have something called a game object PTR, and we go to the code that we just wrote. Here we can see get game object player 0, which returns an optional game object PTR, and then this PO thing here is actually the game object PTR. So it's one of these guys. It has no idea what it's actually pointing to, because it just has a CPP pointer as a member, right? This is a U64. I used to have it as a usize previously. This stuff has actually changed because of WASM. Because WASM by default, and in most cases still today, is actually 32-bit. There is a memory 64 extension to WASM, which should allow using 64-bit types, and it also makes pointers 64-bit large, but support for it is kind of limited still. And so I just figured it's easier to work with 32-bit. Like if a mod uses more than like 4 gigabytes of memory, then we have other problems anyway. But anyway, yeah, this is now sort of rigidly defined to be U64. A pointer is always 64-bit, and Zig treats it as just an opaque pointer. It gets one of these guys, it knows that, okay, this is supposedly pointing to a game object somewhere in the C++ world. I don't really know anything about it, but I can hold on to it, right? And then when you want to get the name for the object, for example, it just asks the bindings, hey, game object get name, I'm going to pass you this CPP pointer here, which I'm told is pointing to a C++ object, and I want you to write the name here into this interrupt string that I'm giving you, and then it can return it as a slice. And that's kind of how it works. Which means that first of all, this is how Zig communicates with C++, even when we're doing DLL stuff. And the thing that I said about kind of accidentally creating the perfect WASM environment is the fact that this stuff actually works across the WASM boundary as well, right? You can't pass pointers across the WASM boundary unless they point to memory that is allocated for the WASM module. Like a runtime, the WASM runtime, at least if it's sort of well behaving, doesn't allow pointing to memory outside of the WASM binary's memory, right? But you can still hold on to just arbitrary numbers that's coming from somewhere. And this would be one of those arbitrary numbers. So with that, the WASM module can actually point to a game object using one of these game object PTRs. It just passes this value, which can be reinterpreted cast to a C++ pointer, and then we get the name using that. So yeah, it gets kind of complicated, and it entirely depends on how your, you know, how you want your mod SDK to work. I don't really see a way of doing this if you are, let's say you're building, I don't know if you're working in Zig, for example. If you are, if you're making your game and you have a nice set of APIs there, and those APIs are just sort of exposing certain parts of your Zig code to, you know, whatever you consider to be your gameplay code, right? And then you would like to make those APIs available to modders and use WASM for that as well. I'm not exactly sure that can be done in the same way. You need to kind of have some sort of rigid and well-defined boundary between the WASM stuff and the native stuff, if that makes sense. I hope this answered the question. I'm kind of pondering out loud here how that could actually be done. Of course, I have a very rigid boundary and sort of interface between these two things, between the C++, like this line here, between these two worlds that we looked at earlier, is very rigidly defined. So even when, let's make this like another color or something. When this thing needs to like ask something from the C++ code, it needs to do so typically using sort of opaque pointers. So this can have an opaque pointer here, and it can go like, you know, get name, and then this guy returns it back. But only here is this thing actually, like, you know, turned into a game. This is horrible typing, game object, you know, pointer like this. And then it can get the name and return it back. So yeah, hopefully that gives you some ideas of how you might be able to do that in your tech. I can't really answer that without knowing what you're working with. Anywho, I bet what is going to happen if we now try to build our beautiful little position reporter here as WASM. Like this thing. I bet what we're going to run into are a bunch of assert failures with the beautiful text unimplemented. We'll see what happens. First of all, it should build. That is like the first thing. It should build. I'm thinking, actually, I realized some time ago that I should have made those assert failures like compile errors on Zig, because you can just sprinkle compile errors kind of everywhere due to Zig's lazy evaluation, and I should really turn those into compile errors. I'm using only C at the moment. Okay, yeah. I could still do something similar. I'll look into if it's possible to share chunks of memory between the game and WASM modules. It is possible, at least with the WAMR module or WAMR runtime. It is possible. Let me think if I can find an example for you somewhere. Where is a place where I've done that in a few places. The base idea is that you need to kind of work on WASM's terms, right? Because WASM is the stricter environment. With C just goes like, yeah, sure, anything goes, and just happily reads anything. for better or worse. So you kind of need to work with WASM's terms, which generally means allocating memory from the WASM runtime that you know that the WASM module can point to, and then writing to that from C, rather than trying to come up with some magical thing that the WASM runtime is not going to like. Let's see, WAMR library. So this guy, if we find it here, malloc, right? Isn't it? Or is it alloc? Thought it was malloc actually, but some doesn't seem to be. Here it is, WASM runtime module malloc. Is that? I don't know why I couldn't find that previously. Okay, this is exactly what I was referring to. So, well, if you're using C, then maybe you want to use WAMR as well, WebAssembly micro runtime. Then you'll have access to this function here. So allocate memory from the heap of WASM module instance. This allows you to get memory that you can write to and read from with both on both sides. Right. So here we're doing JSON management, for example. C factory, that's component factory. Load blueprint properties JSON. So what we want to do here is let me actually see if I can get what's the direction we're going here. Yeah, okay. So we're getting a string. Interrupt string is basically just like almost like a slice. It's a pointer and a length, if you're wondering what that is. We're getting a string from C++, and we want to write that to memory so that WASM can read that JSON, right? The way it needs to be done, or one way it can be done, I should perhaps say, is that you have a native address. This is the stuff that you can read or write with C. You have a uint64. This is just how WAMR wants to represent these things. This is essentially like if you want to pass a pointer to memory that WASM can read, you do it with a uint64. So we allocate some amount length of memory from the module instance, and we get back a value. This is a numeric value. This is what you can then pass to WASM. Here's a memory pointer where I've written your JSON into. Read from that. To WASM it looks just like a normal pointer, but here it's actually uint64. And then you get a native address, and this is different from this value that you pass onwards, because like the memory spaces are obviously not the same. So you get a native address, and then what I do is I mem copy into that. And then this JSON buffer stuff is actually, it's packaged into like a number of uint32s. And here we call a function. So essentially what I'm doing here is I'm having this function which has these parameters, right? As a factory interface pointer, a blueprint properties int pointer, and a pointer and a length for some JSON data. They're exactly the same stuff that I'm passing onwards, but I'm just copying this JSON into memory that the WASM module can read. So it's not super simple, and I've thought about a few ways that I could actually kind of wrap these functions to make it a little easier to work with here, but I don't have that many places where I just work with raw pointers across the boundary. But of course, in case of the DLL DLL library, I can just pass that pointer on. So if we look at not sig whammer library, but just sig library, I look at the same function here. If we have a native library, then this function, which looks exactly the same, this just calls a function pointer. This is a function pointer into, like this, function pointer into the Zig world. And so of course that's going to be a lot more efficient. Anyway, let's build this as WASM now. I'm just going to take that away because I think it builds by default as WASM. So that this guy should get updated. Let's get that. Take away the what. Just build. There we go. We got a new timestamp there. Let's bring that down so that I can see what's happening. And now if we run, oh, actually we need to load that still. Yeah. So trampoline app, just switch that to WASM. And I think this actually, I need to just do this like a whole lot actually to test out this mod layer is by just building things. Probably first making sure that they work as DLLs, because like DLLs generally everything should work there because it's using the same APIs as the actual game. And then at some point just switching it over to WASM and seeing what is not implemented yet. So now if we create this guy, you can see whoop, unimplemented. Bindings API, I don't think I can necessarily even go there, no. Bindings API, oh, it's probably API. This guy, yeah. So get game state. This guy is not implemented. You can see we actually have a lot of these things. If we are doing WASM, then we are not implemented. Else we're just doing the thing. And this might look kind of inefficient to be having this if here, but this is actually compile time code on the Zig side. So depending on which one you actually, which mode you're building this library in, you either get like this or this. So it should be pretty good. And here is where the thing splits when you're calling from the Zig side. We actually have the same thing here that we just looked at in C++. If the call is coming from C++, like from down here and going up to one of these guys, here's where the split is. If we are using a native library, then we're calling this. Otherwise, we're calling this. And from the Zig side, it's here. So if we're calling get game state, so basically like this function call here, this is where the split is. This is handled compile time. This is just a regular Boolean, so this is runtime. However, the calls from the C++ to the Zig side are significantly fewer. To the point where I think it's probably like 1,000 to 1 or something like that. So it's not really that big of a problem. Okay, so let's expose this. Now we're getting to the actual meat of this whole thing. So I've been meaning to automate this for the WASM things, but I haven't gotten very far with that yet. Some of you may know that I have like a whole code generation thing for building some of these bindings. That code generation thing isn't really set up for WASM yet, but I have actually made it so that it helps me out a little bit here. Let's see if we can find the thing. Component context. Yeah, this is the thing. So first of all, it generates all of these extern env function, extern function prototypes essentially that we need to list here, so that the WASM environment can figure out what is it that we actually want. And most of these are still commented out. The ones that aren't, I have actually implemented all the way. And as I am commenting this out, I immediately want to be a bit more specific about some of these things here. So component context get WASM, it takes an interrupt typed pointer. We can't actually pass that. We need to split that into 2 pointers when we're going from WASM to C++, and the return value is a U64, but I actually happen to know that that is a CPP pointer, which, you know, is a U64, but it is more explicit. If we just have this, then some potential reader of this code doesn't know what that is actually supposed to be. It is kind of clear that, okay, it's a C++ pointer that we're returning here. Get game state. Okay, so yeah, we need to split that into 2. Unfortunately. Perhaps the biggest sort of nastiness about this whole WASM business is that WASM doesn't allow you to pass any sort of structured data across the boundary. You can pass integers, and you can pass integer 32s and 64s, and you can pass floats and doubles, and that's it. That's the only thing that you can pass. And that includes like pointers and things. Those are represented by integers. And so this interrupt type pointer consists of two things: an int pointer 64 and a type. Oh, we can't have that. We need to pass those separately. So this is just stuff that I will have to you know, do for all of these things. Some of it I can automate, not necessarily everything. But for the time being, let's just do this. Do the things, expose the things that we need for this to actually work. So where was I? It's self-contexts. That would be here. It was 1077, wasn't it? Yeah, this one. So here I can also be explicit about this, returning actually a CPP pointer. Return. This would be access and component context. Get game state WASM. This is the thing that we just added there. And then I just need to split this. So yeah, I'm hoping to just auto-generate all of this eventually, so that binding and extending the bindings will be easy. Can you explain what extern env string does? Right, so extern basically means that we have external linking. So this is not only used by WASM, of course. You can have other things that are externally linked. But with WASM specifically, it means that we are importing this function, right? The WASM module has some exports. You can see library API. Yeah, here we go. Some functions are exported, and these can be, if you're building a DLL, then this will be exported from the DLL. And if we're building a WASM, they are added to the WASM export list. It had, like, WASM has a section for exported functions that you can call from outside. And it also has a section for imported functions, right? Things that it wants the host environment to provide. And this pub extern is the way to do that in Zig. Env is the what is it that WASM called that? Is it like the namespace or something? Let's Google this quickly. So I don't do anything. I don't say anything stupid. so I've just googled WASM env here, and I think env is kind of like, it has something to do with like WASM is sorry, I'm rambling here. WASM is kind of designed first and foremost to be used from JavaScript, right? If you're writing something on the web, and when you're importing functions, you kind of expect JavaScript to have those functions in you know, some object or namespace or something. And as far as I know, the default one is env. It is what is expected of the JavaScript environment if you don't override it. And basically what I'm doing here with env is just the same thing from the WASM perspective. I need to provide this function so that the WASM module can be loaded, and I do that by exposing it with like the env name. So let's see if we can find that here in the C++ code somewhere. Native function module name. Yeah, runtime register natives, and module name is what it's called. So maybe that is what WASM actually calls it as well. The module name of the native functions. But as far as I know, you can have, you know, call this multiple times with different names. So if you have different, if you want to sort of structure your imports into different sections or with just different namespaces, you can do that. That's kind of like the best way that I can explain it. I think it makes probably more sense if you're using JavaScript, because then you can probably just go like, you know, you have some sort of object, like, you know, const something, const like env is, you know, something, and then you have your like func1, func2, func3. I don't know JavaScript, so this might not work at all, but you know, something like this, and then you can hook that in, and then maybe you can have some other, like, you know, host, and then this has func1, and then both of these can have func1 as long as they have different namespaces, something like that. I just used env because it is what the examples used, and I think, I'm not sure, can you even have pub extern without env? I don't think, or like some name, right? I don't think you can. Let's see, learn and reference extern. Extern. Yeah, they use extern C here in many cases. Actually, let's search for extern and then quote. So here we have extern C used in the, yeah, here we have kernel 32, just like you said. Maybe that's just how Zig kind of expects it to find this thing in kernel 32 DLL, you know, or something like that. It's not something really WASM related. No, it's not. It's just Zig's syntax. Yeah. Absolutely. This is not only for WASM. If you're using extern, then you need to provide, you know, some place for it to be found, right? I think that's probably how you should think about this. You're importing a function from somewhere, you know, this thing, whether it is WASM or not, and you're telling it that it's found elsewhere by this extern keyword, and then this next string is telling it where to find that. That's probably how to think about it. So if you're giving it kernel 32, then that is telling it that it can be found in the kernel 32. And in this case, with the env, it's telling the WASM module, or the WASM runtime rather, that the module expects to find it in something that is named env. Just for WASM, essentially always a list of functions. Something like that. Anyway, that should be good. Okay, so now we have this thing, and we can call it, and I think I already did that. Yes, did that. So, oh, that builds the game. So that's not good. We can of course make sure the game builds. It does, but that's not really what we wanted to do. Instead, what we want to do is this. Now, if we run this, I think we will probably get a different error. So we will get an error about not being able to call that function, right? Yes, fail to call unlinked import function, component context game state WASM, which makes perfect sense. We haven't exported that function. So where do we do that? Get game. Oh, I want to do this. Get game state. Yeah, it's this one. So this is what we ultimately want to call, and it's found in zig interop. And really what I should do here is I should take these context functions and bring them out into their own C++ files. So type bindings in here. Yeah, maybe we'll want to do that. All right, I'm gonna go turn on some lights here. It's getting kind of dark here. Rambling for so long. 1 second. Rightio. Yeah, you'll get to behold some of the really sort of boring things that I've been doing lately, but it shouldn't be all that bad. This is the game state binding, so we can see here that if we're following sort of like the chain of things that we're calling, and we will need to expose the WASM. We have this game state call. That's the first call that we'll want to expose the WASM. And we're kind of halfway there already. Once we have the game state, we will want to expose get game object. So this call to WASM. I can see here that I already have a separate game state binding CPP, so we no need to create anything there, just the actual call. And then finally, we want to expose get world position from the game object. Get world position, I bet we can actually find it here in the main one. So that would be basic sig interop, yeah. Oh, that's camera, let's see. Game object, yep. Game object. Apparently not, actually. Where is it found? It is. Again, I couldn't find it. I wonder what's up with my search. Is my search somehow strangely set up? Anyway, this is what we want to actually... no, that's world transform. Get world position. Or that might actually be using get world transform. Let's see if it is. So get world position. Yeah, it's just getting world transform, then ignoring the rest. Okay. So those are the three kind of calls that we will need to expose to WASM to get that stuff working. So yeah, it's not super riveting stuff, I'm sure, to watch, but it shouldn't take all that long to do. So let's just power through it, and then we can see some new things working here in WASM. So basis, zig. Oh, actually, it's include and then zig, and it is actually type bindings. So game state was the first one. Basis, zig, game state. No, not game state. Actually, there's game object context, game object component context. What do we call that? Let's make sure I don't name that properly. It's component context. Huh. Okay, we can call it that. Basis zig component context bindings. And while we are here, I'm gonna create the one for the game object as well. Game object bindings. Type bindings, and we'll take those two files, copy them here, and change their... that doesn't work. Windows is not smart enough to realize that I only wanted to change the extension, like so, right? This is... yeah, it's probably that one. So, type bindings. What was it called, the thing that we actually created? It was that, and it was that, game object bindings. I should really just put these on two different views here. Sources there, headers there. Let's regenerate the stuff. Alrighty then. So, I have sort of like a standard kind of layout for these type binding things. Let's get like a really tiny one. We can copy that. Core bindings. Core bindings is kind of small. Yeah. Yeah, that looks pretty good. So we'll take that and plonk it into here. And here we have a section for the native stuff, which we already have, but I do a little bit of refactoring while I'm doing this, as I'm sure you can see. We have a section for the native stuff, and then we have a section for the WASM stuff, which is specifically the WAMR stuff, because WAMR is of course the runtime that we use, and other runtimes might work a bit differently. I have all the WAMR stuff behind an if-def, so I can just remove it completely if it turns out that it didn't kind of work out in the end or whatever. Core bindings H, very simple. Take that there. We call this component context bindings. So we bind the native stuff with the C API, and we register the WAMR stuff. they both need to be done if you want to use both kinds of libraries with this binding here. All right. So sig interrupt. Let's go here. This is the huge file that currently contains a lot of random stuff, and I'm kind of splitting it up into different pieces here as we go. So I'm going to copy paste a bunch of things out of that and put it into here instead. So component context. Let's call it just context apparently. It's actually one of the more complicated ones. Might just be like the most complicated one actually. So complicated that it actually has a bunch of helper macros that it requires. Let's see. Sig basis sig interrupt helpers. Oh, we have it there actually. Yeah, okay. Well, that should be good. Okay. I thought it was complaining about these macros here, but I think it's actually complaining about these types. So we just need to make sure that we have those. Something like that. We don't need the profiler. I think we need the threading either. Yep, that looks better. Renderer. Okay. Yeah, so this whole kind of WASM body of work has also just made me realize that some of these bindings were kind of messy. And so I've been spending a little bit of time kind of tidying these things up while I've been doing the actual WASM thing. What do we have here? Transform component. So that's complaining about game object. All right, that we can fix. Physics transform component, character transform component. We just need to include those. What do we have here? Editor component. Okay. Yeah, we need that as well. Still something. Actor. Physics actor. All right. There we go. Physics API. So maybe I can actually remove some of these things now from the really big one. Yeah, this is going to complain that I don't know what these things are, and that makes perfect sense. Instead of doing that, what we actually want to do is bind these things here in our new file, which is not supposed to be called core, but component context bindings. Component context bindings. We need to include the correct one. There we go. That looks better. And then here in the huge one, what we actually want to do is oh, I wasn't able to actually remove that actor stuff there. It was apparently needed. Anyway, let's go here, and here instead we include this sig type bindings, component context bindings, and we take that and we call bind API instead. And here is where we do the WASM registration, so register WAMR. And again, I'm calling it WAMR here rather than WASM because other runtimes might use different kinds of registration sort of things. Here is what it actually looks like when you are making something available to the WASM module. So as you saw there previously when we tried to run it, we got an error that it can't find, like the function is unbound. The C++ side is not providing the function that it tried to call, and so we get an error where here is how you actually register a native function called something, and then you give it the actual function, and then I'll explain these squigglies in a little bit. But that is kind of how WAMR wants you to report what kind of parameters you are actually expecting WASM to call or pass. All right, now then. That looks good. That looks good. And this is the game object stuff. We will be actually doing that in just a second. Yep. All of that looks good. So we are essentially only calling one function here now from this context. Specifically, we are calling self-context get game state. So I'm not gonna bother actually exposing more than that, you know, right now. I know that this isn't exactly riveting content necessarily to watch on stream. So let's try to not do more than we actually need right now. And WAMR wants you to pass this execution environment as the first parameter. So even if we're not really using it, we need to pass it. That's just how WAMR works. So we're going to pass it. So first we have all of these native functions that we can bind directly with function pointers, and then we have a WAMR section where we have the same methods underscore WASM, and they take this execution environment as the first pointer. And here I typically do this. I just basically call into the native side. Now we need to remember though that we actually split this interrupt typed pointer up into two things. I can probably find some other examples of that with this. Yeah, exactly the same thing here. We split this up into two separate parameters because WASM doesn't like structured data. So that's cool. And here we can actually just put it together into one of these again. And then we can return context get game state, and we pass that original pointer. And that's all we need to do really. So now we have this function here. We need to register it. That's the last thing we need to do. Then we will have this first step done. So it's pretty simple, except for this last parameter. Just give it the name, and we point to the actual function. And now this specifies how you actually want to pass return values and parameters. So whatever goes in between the parentheses, these are parameters, and then the return value comes at the end. And now I kind of need to cheat a little bit and look at some other things that I did. Right, so small I means 32-bit integer, large I means 64-bit integer. Yeah, exactly. Okay, so this guy returns a 64-bit integer, also known as a uint pointer t here. So we can put a large I after that. This one we don't want to actually consider. It's not really, it's kind of part of their calling convention. You don't need to specify it here. This is also a big one, so large I and this is a 32-bit integer, so that's a small I. Right, and then these stars and squigglies, like tildes, these are like related to buffers and things like that. Well, that's it. So now if we run this, we should get further. Let's hope I didn't make any mistakes along the way. And yeah, I did spend a few days basically just exposing things. I think I probably exposed some like 200 or 300 of those functions like a day for a couple of days, just to get like the base engine working with WASM like at all. So now if we run this again, we should again get the same message or like a similar message, but we should get, oh, it's still unlinked. That's annoying. Failed to call unlinked import function. Component context. What do we call it? Oh, we call it context. That's why. Yeah, I think we should actually really just rename those to component context. Got to go. Thanks for the stream and answering questions. No problem. Have a good one. Maybe we'll see. Maybe I'll see you in an upcoming stream at some point. Right. So something like that. And just do a. Sure. I could do I could do replace all, but I think I wanna do this by hand just to make sure we don't have any funky stuff up ahead. Looks pretty good. So that, and then we can just do component. Oop. Right. And of course, the arguably most important one is this. We could have just registered that, have it be called context, but register it as component context. That would have worked, but I think I want them to be called component context anyway. Have a good evening. Well, have you too. You too. All right, unimplemented. So we got further. Bindings API Zig 4256. Now, of course, this is now running WASM, which means that we can't just jump to. If this was running a DLL, we could just press break here and we would jump to that place in the code. Can't do that, but I can at least copy this line number here, 4256. And that was API. So it's this, and this game object. Basically exactly what we expected, since the next call is that. Right? And so that shouldn't be super tricky to do. We have the files already created for us. So let's do game object bindings. And basically copy all of this. Game object bindings. I'm gonna leave that there, but just copy, comment it out. Same thing there, and then we need to include the correct one. Right, and get rid of the actual functions there. The Whammer one, I can just leave that for the time being, like so. And then we have this section here. It was called game object underscore. So again, it's this whole thing. It's not as big as that other one. Game object bindings, yes. And we will plonk it into here. And we have some things that we need to figure out here. Render a mesh instance, there's at least one. Game state, we also need that. Put it there. Game state. What else? Mesh component. Come on. Mesh component. There we go. Right. Then let's immediately do this part. Game object bindings. And we can do zig game object bindings bind API. And zig game object bindings register Whammer. Yeah, here you can sort of see like an overview of how much of this I've split out into their own files. So almost half or something like that. And I'm meaning to do all of it. And while I'm doing that, I'm also exposing things to WASM. Slowly but surely. It's not something that I'm going to do like all in one go, probably, because I have a bunch of things on the actual game that I want to start working on. Okay. Now then, this is a little bit of an interesting one. Because what we actually would want or need to expose here is this get world transform. And the reason it is tricky is that it's using pointers, first of all. This works perfectly fine, of course, if we're using a DLL. Using pointers, and it's also using structured objects. This is 3 floats, and this is 4 floats. That's a little annoying, right? We don't really want to do. We don't really want to split them up into like 7 different floats, and even if we did do that, we can't really return 7 different floats from function. That doesn't work. So how do we want to actually do this? It also returns a boolean encoded as an int, so it's an int bool. Returns 0 here if it doesn't have a transform component, so we can't get those things. There are a number of different ways probably that we can do this. One is to actually have Zig allocate some memory for us here. Actual writable WASM memory, which we can then use to actually write the transform to that would be one way. It's always going to be 7 floats, so 7 times 4 bytes. But then we would have to actually malloc here every time we get the game object. Oh, I've been jumping ahead a little bit. I'm already on this get world position. Well, we're gonna need to expose that as well. But actually, what the actual thing that we stopped on this time around is this get game object. This should actually be really easy to do. We can do that next. That would be game state bindings. Streaming utils. Okay, it's in the same. Yeah, we have a bunch of different things. We have like game state here. That should technically be like that. We have game state, we have nav mesh runtime, and we have streaming utils. All in the same file. That's completely fine. It's probably what I considered at the time to be kind of related. So we're going to do game state, and what did we want to actually have? We wanted to have get game object. Alright, so the very first function. This is one of those that is kind of simple to bind to WASM. Just again, we take this, make the first parameter be this execution environment, and then we'll just do game state, get game object, pass it the CPP pointer in the name hash. That looks good. I'm just going to copy that down here so that I can see what I'm doing. So it is it's taking a 64-bit integer and a 32-bit integer and returning a 64-bit integer. Like so. That's it. Yep, that looks good. And then we need to basically do the same thing here. So return. Oh, actually, get game object. Yes, we need to make that available to us. So base is CPP pointer. And that's it. That's all we need to do. And now we can call it. So library API, isn't it? Or is it? No, it's API. Just there we go. So return access dot that game state get game object. We can pass it CPP pointer, and we can pass it game object or object name hash. Yeah. And I'm so used to hitting Control Shift B here that I do it every time, even though I'm actually building the game that way. Yeah, the mod now works. Okay, so now we should actually be able to call this. And we should now get to that last one. We create one of these objects here. So API Zig 920. And I'm hoping that is the get transform. Yeah, get world transform. Right, so now we are here. We've gotten the game state, we've gotten the player object. The player object is valid, so we're doing this, calling get world position in WASM. And yeah, I don't know exactly what to do here, or I haven't decided exactly what to do here. So, in order for the actual game code to not have to worry about whether this is WASM or not, we are going to be packaging up this transform into an interrupt vector, and an interrupt quaternion and returning a C integer here. So it's essentially giving us, hey, write the position here, write the orientation here, return 0 if you couldn't find anything. That sort of deal. And so, how would we actually go about doing this then? Yeah, maybe we'll do it with a... I mean, we shouldn't... Yes, we can do it exactly like this. We do it exactly like this, and we've actually already been... We were just in the same file that does this thing. I don't need to malloc anything. I don't know why I kind of really thought I would have to do that. I can just... Because I know it's always going to be a 3D vector and a quaternion. I know it is going to be 7 F32s. So I can quite simply create a buffer here in WASM memory and just tell it, hey, here's some memory, write the stuff here, and I'm going to be deserializing that later. And here we actually use a binary read stream to then get back. You can just like get a vec3 out of that. Yes, this is how we're going to do it. It's going to be glorious. Let's look at what this actually looks like. So, to be able to pass pointers to and from WASM, there's essentially only a single kind of pointer that you can pass to WASM and from WASM, and that is just a straight byte pointer. And if you do that, then the next parameter after, here's the byte pointer, the next parameter should always be the length of that, at least with the WAMR runtime. They really hammer home in the documentation that you should do that. So let's do it. So this would be game object get world transform here, that one. Let's do it like that. I'm gonna comment that out, just have it there as a reference. Value buffer. It's going to take the CPP pointer. That is completely fine, and we need that. But then we will replace the position and orientation with the value buffer pointer. Yep, that is how we want to do it. So now we can go back to API. We can copy all of this. We're going to do almost exactly the same as this. Game object get world transform. We don't have just a position. Actually, we have a position, and then we have, let's see, const q is stream get basis math quaternion, and so orientation dot star or dot asterisk is q to interrupt, and we need the buffer to be larger, so 7, and then we need to call the correct function here. That's important. Game object get world transform WASM. Yep, that's it. So I hope this makes sense. We're declaring how much space we need. We allocate some actual memory that we can both read and write from both C++ and WASM. And the reason we can do that is because this is actually declared here in WASM. We can do it. We can do the opposite thing. We can't just declare a buffer in C++ and pass that to WASM, right? That would violate the sort of security sandbox sort of principles. Then we call down into C++ and tell it, hey, here's a buffer, and we want the world transform. Just serialize the world transform into that buffer. And once that has finished, it should be there, so we create a stream. We get a vector3 and a quaternion out of it, and then we essentially write to like an interop version of that. This is a little stupid because like eventually what we will want to end up with is like a vector3 and a quaternion. So we're actually getting that, and then we're going through an interop layer, which then, you know, turns them back into a vector3 and a quaternion. The reason it's done like this is because the pointers here on the native side, they can't be a vec3 or a quaternion. They need to be an interop vect or interop quaternion because these are marked as extern struct. So these work with just like the C ABI. So we're jumping through some hoops here on the WASM side, but it's probably still the better thing to do than having to change the native side. Okay, what are we getting? Oh, expect the 3 arguments. Yes, exactly. This guy needs to be passed as well. There we go. CPB pointer, value buffer, and value buffer length. And we have even more things. So, what do we call this? Like ret for return. So if ret is 0, we should return ret here. We shouldn't try to do anything else. And here we can return ret. Yeah. So we're essentially always returning what this thing returns, just like we're doing here. The important thing is that if this is 0, we shouldn't try to actually write read from that at all. Yeah, that's essentially the important piece. Okay, I think this is all we need to do on the Zig side for this whole thing to work. But of course we still need to actually implement this in C++. Shouldn't be super tricky though. We're almost there. Now if we stop this and run it again, and we create one of these, we can't call that one. But that is the last piece of this whole puzzle. So let's go to game object bindings. We have this guy here. And I think this might be a case where I actually don't want to call into the native version of this. That makes sense, but because what we're doing here is kind of different from what the native version does. So like typically I would have done something like return, and then we just take like this part here without the WASM, you know, and pass the things on, blah blah blah, and then do that. But I don't think we want to do that at all. Instead, what we want to do is have a little bit of custom logic. Let's go to game state bindings and we'll find this get streaming position. And we can see here are the types that we want to have for the parameters. So again, this is the only kind of pointer that you can get from WASM, from a WASM module outside of the WASM module. It's the straight byte buffer. Okay. This sort of thing we can do. Actually, we can do all of that. Just copy paste it there. And we can do return 1 here so that we don't forget to do that. Okay, so now we'll want to actually serialize this vector3 and this quaternion into that stream. That makes sense. Let's see. String utility, I don't think we need that. We don't need the OS dialog. Probably. What we will want to have is a core binary stream. And then we'll do binary stream, and value buffer pointer, value buffer length. And I probably need to cast this to something. uint 8. Okay, what does this actually expect? It expects the basis byte, which is basically like a... It might be like a signed version of that or something. Oh, which one is it actually? Oh, just okay. Yeah. It just wants the true there. There we go. That's good. That's good. And then we can do stream put p stream put o. That's it. That should work. Yeah. We can't forget this though. This is important. And now, what the thing actually takes as a as parameters is it takes a large I. That's like this uint pointer t here. Again, we want to skip that guy. That's a large I. That's a 64-bit integer. Then it takes a buffer, and that's represented by star. And then a tilde that comes after the buffer. That is like the length of the buffer. And then what we are returning is a small I. That's a 32-bit integer, this int bool thing here. And even if you're actually returning like an honest-to-God boolean, you're still represented by a 32-bit integer when using the WAMR runtime. Okay, I'm hoping this is now everything we need to do to actually have that position being reported to us here. So that took quite a lot of work. And look at that. We have our vector tree visible, and again it looks very much correct and sane. So quite a lot of work to actually get a value out of WASM. Of course, I'm doing like a little bit of refactoring here while I'm doing this, so it's not all just like the WASM's fault. And of course, none of the people actually making mods will have to touch anything like this. You can just use the same Zig interface thing as I do when I'm actually making the game to write your mods, and it should, at least in the majority of cases, compile to WASM as well. And I want to make it so that like if you're using some of the interfaces that aren't available in WASM, it will just like not compile. And that shouldn't be really a very tricky thing to do. Just turn some of those unimplemented macros into an actual compile error if you try to use an API that's not WASM compatible from a WASM mod library. But yeah, that's it really. Does anyone have any questions related to this? I know I've been rambling for quite some time now about this whole thing. is above my pay grade. Oh. It can get a little complicated sometimes. Mostly it's kind of just like boring stuff. The good thing is that that the bindings just become much more robust when doing this. It's not that they've been bad. I'm actually kind of happy with how well the whole SIG binding thing works in this engine so far, but there's been a lot of just like assuming that we have a single library loaded and poking at global data and things like that. And now we actually, like, a pretty significant part of this whole work was just making it so that the engine can load, 2 of these libraries now. And actually, even if they are both DLLs, even if there's no WASM involved at all, data kind of flows back to the correct library and all of that. That probably took me like a week to just untangle that stuff. I haven't yet addressed scripting in regards to modding for my engine, but the file system already makes mods trivial. All file system volumes where the folders and pack files are mounted into one global space, so mods can non-destructively override anything. Yeah, that's one thing that I might want to think about a little bit with the mods. If I could actually make it so that they could override things. Like, the game doesn't really use the file system except for a very few select cases, like the videos are streamed directly off disk, so they're not coming from a pack file. But the things that are coming from actual pack files, which is like everything else, that stuff, it shouldn't be super tricky to actually make it so that you can override things, but you can't do that currently. That would be very handy. So the way that this, like, I don't know if you can see this text here. I can't unfortunately make this larger right now, but we're running a command called gamestate.createObject testmod/testObject, and then placing it at the world origin. Conceptually, it doesn't really have a transform, so it doesn't matter. It doesn't care about that value there. But this testmod/testObject thing, that is an actual blueprint which is found. Oh, I think it's actually found on desktop currently. Yeah, testmod res, testmod resources. So these __ something, these are just part of the game engine. You shouldn't really care about that. But like, the way that you can add resources to a mod currently is by having a resource pack, and these work just the same. They're exactly the same as the resource packs that come with the game. They are just not monitored by the asset server in the same way as those are currently, but they conceptually work exactly the same. You have a folder, in this case testmod_res. That becomes pack file, and I have inside of it just the blueprints folder, and here testmod.blueprint. If we open that up, because here is this testmod/testObject object type. So this is exactly the same format that the blueprint editor creates for us, and I'll probably make this tool available to mod makers somehow. Not like this thing when we actually had add components from here, for example. If we go and actually have a look at what this looks like, just explore to that and open that up, you can see that it is this format, which is the same as we have here. And so it's just a normal blueprint that the mod kind of provides and which also happens to be using the new component type that we created. And then I just have a batch file here actually, which we can just run, and this produces this this testmod underscore res file in the BP4 format. So it basically like writes the I lost my folder here somewhere, but I can navigate to it. It's in basis, means mods output test mod. So it creates that file. Test mod res BP4. But it would be really cool if you could actually override files in the base game. I'd like to have that as well, but I currently don't. And that would mean that we could like just override the list of components that get added to this car, for example. Currently, the way this modding system is set up is it's more like you can add new things more so than you can edit existing things, if that makes sense. But it shouldn't be super tricky to make it so that you can actually modify the existing stuff as well. But I'm gonna be a little bit careful with that, because like you can quite simply, like I don't mind if anyone turns this into like a monster truck and then drives around. That's just fun. But like I want to be a little bit careful with it in the sense that you can quite easily like break the game if you start overriding things willy-nilly. So we'll see. We'll see. But okay. I think I'm probably gonna end this stream relatively soon. This was pretty good. I got some good questions. Hopefully I was able to answer most of them to your satisfaction. I mean, this system still works after this this first test, which is fun to see. Yeah, I've been just like working such crazy hours with this whole WASM thing, because like I'm actually not really doing Madrigal work this week, and not the next week either. I am working at another company for this week, and then I will get back to Madrigal stuff later. But I was kind of hoping that I would get like the base for the modding system done kind of during evenings during this week, and it kind of looks like it is coming together, so that's nice. That means that then when I get back to doing this game almost full time again for a little while, I can concentrate on other things and just have the mod system be there sort of in the background and like getting improved and more stuff bound to WASM as I go. So that's really cool. And almost more than anything else, I just want to start working on the next large area, because I'm just kind of sick and tired of looking at this level. Interesting stuff, like usual. Oh, well, thank you. Thank you. I hope it was interesting. Yeah, I feel like WASM is very interesting, but it's not without its issues, and it's not always super easy to work with. I'm trying to make it super easy for people who make mods. I'm trying to make it super easy for those people to work with WASM within the context of this tech, at least, by simply flipping a switch when you're building your stuff, and then everything just works. Off you go. But we'll see how that works out. And of course, if you don't want to write any code, if you don't want to write any logic, this system is also supposed to work with just pure data mods. If you just want to make a level, you want to take the existing assets provided by the base game, and you want to open the level editor and just make a level, maybe paint some terrain and some grass and stuff like that, and perhaps add some sounds or something. That is supposed to be supported as well. You don't necessarily need to write any code at all for a mod. It can be just like a purely data mod. That should be possible as well. But yeah, like I said, I very badly want to get away from this environment. It's almost done. There's still a few houses in the lift station that aren't modeled, and I probably will do that relatively soon. Let's open the main gate here. You can drive into it. Yeah, so we have this. That house over there is not textured yet. And that whole area with the cave is kind of weird and kind of without purpose. And then we have a house over here near the monorail station, which is also very, very rough. Other than that, I think this area is kind of starting to come together quite nicely now. Maybe some trees up there on the cliff, things like that. But then I want to, you know, go somewhere completely different. And start laying out the whole campaign, essentially, or at least the first sort of campaign as it will be when this launches on Steam. Hey. And yeah, I think it's kind of it's time we actually got some other environments to look at. I kind of like this level, but I feel like I'm getting kind of sick of looking at it, and I'm sure you're doing that as well. Coolio. That's that, I think, for today. If this stuff looks interesting, then make sure to subscribe, like the stream, join the Discord if you want to discuss this in more detail. Also, if you join the Discord, then you have the chance to actually play the first pre-alpha 1 build, which has been out for about a month now, and allows you to play that level that we just looked at. A link to the Discord should be in the description down below. So by all means do that. This looks fun. Yeah, anyway, I'm probably gonna end this pretty soon. My brain is getting kind of fried because I've been working such long days with this system. I'll probably keep working on the mod system while doing other things next week, and then I'll be back at some point. I think we'll be doing like one more mod stream, or at least one more mod stream. We'll be like actually building a mod. I think I'm gonna do something kind of crazy, like make like a weapon or something. Like there are no weapons in the base game, and I don't think there will be. But it might be kind of interesting to have a weapon as a mod, which I would be releasing as like open source when the first version of the game that actually has mod support is then released. Which hopefully is the next pre-alpha build, but I can't promise that. We'll see how it works out. If I run into some super bad WASM issues or something, you never know. And never know what's gonna come down the pipe. But yeah, I think we'll probably do like one stream where we'll actually be writing that mod. But for that to be possible, I need to solidify the mod system a whole lot more. Make a bunch more things available to WASM, and just make like the mod loading better, so that we don't need to have this hard-coded mod description here, like this thing. You should just go away, and instead it should just evaluate all of the mods, or enumerate. I keep saying evaluate. Enumerate all the mods in like a folder, and then load them, and allow you to disable and enable mods and so on. But yeah, that should be fine. Anyway, thanks to everyone who came to hang out today. Do remember to do all the YouTube jazz, liking and subscribing and all of that. And I'll see you next time. Have a good weekend, everyone.